Hello guys, welcome to this new session. We will continue developing our Ant language. So let's continue building the OOP concept. So previously we've accomplished the methods, and in this session we will treat this keyword. And this keyword it refers to the current object. So let's see this example. We have a normal class declaration with person and with a method each that accepts a parameter something, and then it prints the concatenation of the string each in plus that parameter, and then it prints this. This is a variable, special variable that hold the reference to the current object. So let's see the instantiation. So we have p person, and we create an object here. So this, it will refer to that object p, to that instance. So when we call the method call, the method should print eating pizza, and also it should print person instance. So let's see the bytecode. At the level of the method eat, I treated this keyword like a local variable. So this local variable should be at the 0 position. So that's the idea. We will treat this as a local variable. So for the bytecode of the calling the method is the usual one. We get to the instance, and then we load to the argument, and then we do the invocation with that name it and the number of argument. So let's jump right to the code and see what would happen if we just compile our we compile this keyword without modifying our VM, and we will see how the invoke bytecode will interpret that. So let's go to our compiler.c, and what we need to do is to go to our init compiler. So here, remember that we add this empty string for function calls, just because we've developed the frame call. So the position 0 is reserved to the function name. So in this, what we need to do is to check if the current or the type is different than type function. Then what I need to do is to copy that here. Let's copy that one. I need to store at the locals array a variable with the name this, and that's what we want, and with the length of 4. So in the position 0 we store this with its length. In case of a type of function that is not a function, so it could be a method, a initializer function, or in case of a script, I will treat that so that I can prohibit the use of this in the top level of code. So otherwise, any type of method, any type of function, we will store just an empty string with a name. So let's go to the rules, and in this we will treat it as a prefix token, prefix operator. So I will call the function this, and I will declare it here. Static void this can assign, and I will go after that, and then I will add it here. So static void this all can assign. So I will check if the current compiler type different than type method. That means this is used outside a method, we need to raise an error, because this, it will be just used inside a method, not outside a class. So can't use this outside a class. And then I will call the variable false, and it will call the variable, and it will emit the bytecode of get local with the position 0. It will search, which it will resolve this, because the previous token is this, it will resolve it by searching at the locals, and it will find this at the position 0, then it will return that index at 0. So let's see what happened if we use this. So let's make clean and make all. So everything is good. I will go to the sample, and let's remove that, and also that, and I will use this here. Print this, and you will see the error that we will have. So let's go to common to see the bytecode, because we have let's clear that, and let's interpret that another time. So let's see, we are in the p.8, so this is the invocation of 8, and we will see what happened in the instruction 21. So in 21, as you see, previously I have the person instance with the pizza argument, and also the instruction invoke. What it does, it search at instance. If it found the 8, it go to the class, and it found that function, and it put it at the same place of instance. So when I need to get local 0 for this variable, it will get that one, and that it's false, because our interpretation, the VM interpret the invocation by putting that function in the place of the person instance. So what we need, so in the old version, this is what we've done with invocation. We change this person instance with the closure 8, and then we run the function 8. So that's we will change it right now, and we will place it with something like that. We will not replace that person instance with the closure 8. We just create a frame that point to the closure 8, but the position of the person instance, it will stay person instance. So when I will the VM call got operation get local 0, it will get that one, and that's what we want. So let's jump right to the VM and see what we need to do. So let's go to the VM, and in invocation, so we know that the method it doesn't exist on the fields, but it does exist on the methods of the class. So here we change the place of the person instance with the new value of the closure. So what we need is to remove that line, and I will call directly the value as a closure. So that's it. So excuse me, so let's come back and clean the project and this. So let's get sample and let's run it. So let's go to the instruction where we have the invocation, so 21, and as you see in the 8 we have a get global local, and we print it at the position 0. So this is the variable this. So let's go to the 21 instruction here. As you see before, we have the person instance and we have the argument pizza, and when we do invocation we did it on that and the argument that. So as you see here, we have some invocation, and then what's happening is that we didn't change that position, that location of person instance with the closure each. And here, from here, the method each will be executed, and as you see, we have the person instance at its place. So when we call the get local 0 for this this variable, it gets that position and puts the person instance, and then it print it, and that's what we need. And here in that case we treated this keyword. So let's see if we use this outside at top level code. So I will run that, and as you see, there is an error, can't use this outside a class. So let's remove it. So we choose that. So there is one more thing I need to mention. So let's go to dot, and we will comment the optimization that we did for method calls, and we will do just the old version with getting the closure and doing call without a invocation. Without using operation invoke, we will just use 2 bytes to represent a call of a method. The first one is getting that method, and the second one is calling that method with the byte code of call. So let's see and interpret for the second time. Interpret the same script. I did something wrong. Okay. So let's run our end interpreter on this same sample, and we will see we don't have invocation, but instead we have the invoke. We have the opcall bytecode. So we get the property it, and we have the argument pizza, and we call that property with a argument count 1, because we have just one argument. So let's see what's happened. The instruction 19, as you see, previously we have the instance person, and when we get the property we change that with a function each, the closure each, and that's not what we want. We need to preserve that place with the person instance. So when we call the get local 0, it doesn't get the closure, it should get the person instance, because it reference to this keyword, it reference to the current object. So let's fix that. So before fixing that, I will present you how we will do that. So the issue happened when we use the op-get property it. So we need to create another object that hold the person instance, and also it hold the closure. That object called bound method object. So this one, it will point to the person instance and point to the closure that we need to call, and that object we need to push it to the stack. As you see here, we push that object to the stack, and after after the bytecode of call, the receiver must be pushed, and the value of the receiver is the person instance. We will push it to the stack, and we will remove the bound method that we have previously. So let's go and create that bound method and do the ordinary stuff, and then we will go to the VM and create that bound method in a operation called opget method. So I mentioned that problem in this case, but in every case that it has obget property and closure, it's on a method class, we need to return a bound method, not a simple closure. So this is just an example, but the obget property, it will be used at every situation. So let's see, and we will create that object. So let's go to our object.h and let's add object bound method, and let's add the usual stuff, define as bound method with the value, and I will cast that to be bound method. We will add that structure later. And let's add one more, is bound method is object type value object bound method. Okay, so let's go here and type the object bound method, and it has the usual header and also a value for the receiver and also a object closure for the method. So no, I need, yes, for the method. So let's create a function that create that object for us. Object bound method. So new bound method value receiver, and the method closure method. So let's go to object.c to implement that. Object bound. So guys, this is the last object we will create in this project. The bound method object is the last one in this project, the end language. Bound method. Okay, we need the receiver and also we need the closure is the method. So let's create it. And method, we will allocate that object bound method object bound method, and okay, I would rename it bound. So bound receiver is the receiver and bound method is method, and we return that bound. Okay, so let's print that case object bound method. I will treat it as a function, print function, and as bound method on the value that, and I will call the method, and I will get the function. So that's it. So let's go to memory to deallocate that object. So case object bound method, and we will free objects and objects, and will break. So that's it. So let's rebuild the project and see if we have any issue. So until now we didn't have any issue. So let's go to the VM and treat that on up get property. So in the case of up get property, in the previous version, we just check the class and check the table of methods, and if we have that, we push that value in the top of stack the closure. So that's what we don't want. We need the top of the stack should be a person instance, so we can get the local 0, because the local 0 should be a person instance, because this, remember, this keyword, guys, it refers to the current object. Move that and that and that and that and that and that and that, and what we will do is to check if bound method on that class with that name of the method, and then if it does return true, I will return interpret runtime error. So let's develop this bound method. So let's go here, static bool bound method, and it accepts a object class and object string for the name of the method. So I will have a variable method to hold the closure, and if table get on the class and doesn't have that method, what I need to do is to raise a runtime error and define property, and the property with that name Charles. Okay, and I will return false, and I will create the bound method bound, and I will use the function new bound method, and I will pick top of the stack is the person instance. The example is the instance, and for the closure is as closure, and I will pass it the value method, and I will pop the value from the stack, and I will push that bound. This case it happens, that case. This is the case. So the pick 0, it has the person instance. Why? Because we have the get global p before the get property, and in this get global p it's the person instance, and I will pick it from the stack, and then I will create this object. I will create that object that point to the person instance by the receiver, and it has the closure method each, and then I will push it to the stack. So that's what I did here. So after that, the bytecode that must be called is opcall. So I will go to call value and update that to treat the case object method bound And in that case we have on the stack the bound method. So after the call I need to put that receiver, the value of the receiver person instant, in the top of stack. So I need to pop that one and put that instead. Basically what I will do is to get the object bound method from the stack, bound, okay, as bound method, okay. So I will update the position stack minus arg count -1, and I will put bound receiver, and then I will return call on bound method because it is a closure, and I will pass the argument count. And by that, guys, we resolved the issue of we don't have at 0 position we don't have the person instance. So let's go and here top. So let's rebuild the project and see. Okay, so in error vim.c bound method excuse me. So let's so everything is good. So let's go to the sample and see what we have. So let's see if in that case it print what we want. So here we need to return true. So let's clear that. Let's and see what it prints. So as you see, we get property constant and go out from 17. So let's go to 17, and as you see, we get the instant, we get the property eat. Okay, we get the property eat, and then okay, yes, we get the property eat, and we have pizza, and we call that. So as you see, this one is a bound method, so what we need to do is to change that position with person instant, and then the call it happened for it, and then we will print it in, and then we do the rest. And when we get to the local 0 for print the keyword this, we load it to the static person instance, and then we print the person instance. So that's it, and we solved the issue. Okay, so let's clean the project and see without any debugging. 18 pizza, and we print the person instance. So that's it, and we reached our objective for that video. So that's it, guys, and we treat the bound method object. And let's do another sample. Let's do eating, and I will add this dot age could be 20, and I will print p dot age, and we will see. So here we set a property to the current object with the property age with some 20, and then we print that. So let's see. So as you see, guys, it print the age, so it worked. So see you guys in another session, and we've reached our objective of this video. We developed this variable. So see you guys in another session to treat constructor or initializers, and it will instantiate an object. It will be called at each instantiation of an object. So see you guys in another session to continue developing the concept OOP in our language end. So see you guys.